Hey everybody, Trey here. Welcome back to another forecast discussion. We've got another severe weather threat on tap for today across parts of far southeast Nebraska, parts of central and northern Kansas, down through northwest Oklahoma. Slight risk there outlined by the SPC with a surrounding marginal risk. Any storm that does fire will have a tornado threat along with an outside chance for damaging wind, but most likely large to significant hail. Now, this is going to be a setup similar to yesterday's event where we had that dry line cold front intersection up in northeast Oklahoma, and we expected storms to fire up there on that triple point, and they actually did, but they were unable to sustain themselves due to quite a bit of subsidence on the backside of a departing shortwave. And we're going to be fighting the same battles today. We're going to be fighting weak forcing and subsidence associated with some upper level ridging over the region. But any storm that does fire will be able to take advantage of a pretty good parameter space for supercells, perhaps some tornadic, as well as some large hail producing supercells. So let's go ahead and get started here. We'll take a look at our satellite imagery here. This is our water vapor imagery, and you can see exactly what I'm talking about here. You can see this kind of ridging right over the central and southern plains, and we can see that we're caught between these kind of two troughs here, the one here in the Great Lakes region, and then this one that's digging down here into the Pacific Northwest, into the west coast. So we're kind of caught in between these two. This one out here to the west going to be our main focus, our main driver for severe weather tomorrow, Friday. But for now, we're caught kind of in between these two troughs, so we have some ridging ongoing. And as we know, when you're in the exit region of a trough, that promotes rising motion and storms. And when you have ridging overhead, that promotes sinking motion and fair weather. So we're going to be fighting this sort of lack of forcing and somewhat decent subsidence associated with this ridging aloft, much like we did yesterday. Let's take a look at our visible satellite imagery here. You can see we've got quite a bit of low cloudiness across the plains here. You can see we've got kind of a warm front in here, and I'm going to show you the surface map here in a second associated with this surface low kind of in the West Texas region, the Texas Panhandle. So we've got that warm front there, quite a bit of low cloudiness here, and that should burn off throughout the day here. I would expect we'll get quite a bit of clearing up here, up in the target area later this afternoon as these clouds burn off. But let's look at the surface map here, so we can take a look. Number one, at where our moisture is, and number two, where our surface features are. So you can see that those 70s dew points still confined down here to far south Texas, toward the Texas Gulf Coast. But we do have mid-60s up into central Oklahoma here, up toward that warm frontal zone. And you can see exactly where that is. You can see we've got kind of cyclonic circulation there in the low levels, centered somewhere in the Texas Panhandle, kind of close to Amarillo there. And then we've got this warm front. You can see the clear wind shift there, kind of centered right over the OKC metro area, maybe just north. You can see the wind shift here, winds out of almost the due east here to the north, out of the south-southeast here to the south of that front. So clear warm front here, and that is going to retreat northward as we go throughout the day. That low is going to kind of sit there and perhaps intensify a little bit, and given this southerly flow to the south of that warm front, that should be able to push the warm front a little bit toward the north, probably setting up somewhere near the Oklahoma-Kansas border, maybe creeping into far southern Kansas by late this afternoon. And just like yesterday, we're going to have a dry line set up as well. You can see the dry air out here to the west, 28 here at, I believe that's Hereford, and then 11 dew point here in eastern New Mexico. So very dry air to the west here, and that's going to promote dry line formation here as we continue to get that southeasterly flow, pumping that low-level moisture up into the region. We're going to kind of get another sort of case where we have a nice triple point here. Wherever that warm front sets up and meets with that dry line is where we're going to have enhanced convergence and perhaps enough to overcome the lack of forcing and any capping inversion that remains to initiate storms here, up perhaps into the eastern Oklahoma Panhandle, far northwest Oklahoma, or far southwest Kansas, somewhere in that vicinity. We're going to have to watch observations today closely to see, number one, where that warm front sets up, and number two, where that dry line sets up and where it will intersect with that warm front. That's going to be the best best chance for storm initiation is going to be along that triple point. So let's go ahead and look at our upper air pattern here. So we have our 500 millibar map, and you can see exactly what we saw on the water vapor imagery. Trough located here over the Great Lakes, trough digging down here into the Pacific Northwest, into the West Coast. and we've got this sort of ridging here across the central and southern plains. So generally not very favorable for severe weather, given you have subsidence associated with this kind of upper level ridging. But the question today is going to be, can we get enough convergence along that dry line front intersection to help overcome that sort of lack of forcing? Now we will have some storms likely up here in probably central and northern Kansas, up into southeast Nebraska here, along the warm advection regime. Given we have a pretty solid low-level jet in place, or we will have a solid, pretty decent low-level jet in place throughout the day, and probably increasing after dark. So we're going to have this sort of low-level flow pumping that moisture in, overrunning that sort of warm frontal zone, and we should get some convection up here into northeast Kansas, southeast Nebraska. Again, these are going to be elevated storms, so the threat for large hail will be there, but the tornado threat will be minimized. But if we can get storms here again along that dry line front intersection, we should have a chance for tornadic supercells out there. We will have some sort of low-level jet throughout the day here. You can see 30 knots or so here across Oklahoma and Kansas in a few hours. It's going to kind of translate to the northeast. But we're not going to have, this super low-level jet over the plains. We're not going to have continued lee cyclogenesis here on the lee of the Rockies, because that trough, again, is going to be sitting well out here to the west. So we're not going to have that influence of that westerly flow over the Rockies to get that surface low development and that associated mass response. So the low-level jet may remain pretty weak throughout the day today, adequate but pretty weak throughout the day, and it could strengthen after dark, as is the usual kind of diurnal cycle with the low-level jet here in the plains. We'll take a look at our surface map here, so you can see where that surface low is, kind of located across the southern Texas panhandle there, with the warm front somewhere across central Oklahoma. And again, that's going to lift northward throughout the day, given that southerly flow to the south of that front. Again, probably going to set up somewhere up in here, Kansas-Oklahoma border, into far south Kansas with the triple point, with the dry line there, somewhere up in far northwest Oklahoma, perhaps the eastern Oklahoma panhandle, or far southwest Kansas. Again, it's going to be an observation kind of day where you have to look at the observations to know the best spot for storm initiation. So let's look at some soundings now. We'll take a look at the 12Z soundings, and this is the Norman, Oklahoma sounding from 12Z, 7 a.m. Central Daylight Time. And you can see very steep lapse rate plume aloft, and that's going to be associated with that elevated mix layer. Again, you get that dry air to get pumped into the central and southern plains from northwest Mexico, the desert southwest, along that kind of southwesterly mid to upper level flow. And so that very dry, warm air aloft in place today. So the atmosphere is going to remain pretty capped throughout the day. And given the lack of forcing, this may be a little bit difficult to erode. However, given surface heating, I think we do have a chance. If we look at what our convective temperature is, it's going to be 92 degrees Fahrenheit. I don't expect us to get that warm today, given we have some low clouds in place that may be a little bit slow to burn off. So I don't know if that's going to be the case today. But let's say we get into the mid-80s here. And just for, giggles, let's look at the Oklahoma City forecast temperature for today. It's going to be 82 degrees Fahrenheit. So if we get up to 82, that's going to help erode some of this cap. And if we have that enhanced convergence along that triple point, that dry line front intersection, that may help allow storms to fire, even if we have a little bit of lingering convective inhibition. And if we get even warmer than 82, up into the upper 80s, I think we'll have a very good chance of breaking this cap. So this cap may be a little bit stubborn, but I think given surface heating and that the forcing from that triple point, that localized area of lift from that triple point, may be enough to erode this cap and break through this cap and get surface-based storms. That's going to be in question, of course, but something we'll have to watch. So again, very steep lapse rates aloft, already quite a bit of instability here building, already almost 2,000 joules per kilogram of mixed layer CAPE here at Norman at 7 a.m. So very conditionally unstable atmosphere here, and definitely an atmosphere favorable for very large hail in any supercells that do form and sustain themselves. Fairly shallow moist layer here at Norman, only goes up to about 900 millibars here, so that may be a little bit of a concern. The depth of the moist layer is fairly shallow, but I don't think we're going to have too much of an issue today. we may have a little bit of a problem with dry air entrainment. That may inhibit the sustenance of any supercell that does fire up on that triple point. But something we're going to have to watch today. Definitely a few red flags with the setup today, but again, I think the parameter space is going to be there for supercells. You can see some low-level warm advection ongoing. We already have some decently looping photographs here, clockwise curvature in the photographs. So warm advection is ongoing here in the low levels, as we saw on our surface map there. And so it's definitely a conditional environment for supercells today. We're going to have to watch how this cap erodes. I think a lot of the models do have this cap eroding decently throughout the day. And we are going to have to watch how warm does the surface get, where does that dry line front intersection set up, and is that going to be enough to fire storms and allow them to sustain themselves. So definitely a conditional environment. Let's take a look here at the models. We'll take a look at the 12Z NAM that's coming in right now. You can see as we go throughout the day, this is the 500 millibar map. We're just not going to see any sort of forcing from a shortwave or anything here across the central plains. Very ridged throughout the day, and it's going to stay that way, caught in between these two troughs out here. That's going to be the main drawback for today, is this lack of forcing. And we'll go down to 700 millibars and show you we just don't have any sort of shortwave trough here. Well, now that I look at that, that may be a little bit of a shortwave in here. Very subtle, but that is interesting. That may be enough, actually, by mid-afternoon to initiate storms here and help lift that cap a little bit, lift and cool that cap a little bit. So I actually am a little surprised to see this here on the 700 millibar map. We do have maybe a little bit of a shortwave, although the main axis may be up in here. So that may be a little bit worrisome that we may have some subsidence back in here. But given this depiction, we could have maybe a little bit of a shortwave back in here that may help things. Very hard to say. It's nonetheless going to be very, very subtle if there is a shortwave. So I'm not sure it's going to be enough to remove the sort of conditionality of the setup, given the ridging aloft. This is our 850 millibar pattern, and you can see we kind of have that increase with the low-level jet after dark. So this is something that the setup yesterday did not have going for it, in that it had the low-level jet was kind of departing yesterday. Shear was decreasing throughout the day, and the fact that we have a low-level jet kind of ramping up towards sunset, between 21 and 0Z, you can see we start to ramp that up, and then after 0Z, we really start to ramp that low-level jet up. That may help sustain any storm that does fire, whereas yesterday we did not have this across northeast Oklahoma. So that is definitely something that today has going for it that yesterday did not. Very strong low-level jet here by sunset. You can see 30 to 40 knots here, even up to 50 knots here between 0 and 3Z. So the wind shear profile should be pretty solid here, given sort of southwesterly flow aloft. So you can see the surface map here. Let me zoom into the southern plains sector so you can get a little bit better view. So you can see that surface flow, southern Texas Panhandle, lifts northward a little bit throughout the day. This is at 21Z, and you can kind of see where that warm front sets up. It's going to be kind of somewhere in here, perhaps a little bit farther north. So it's hard to say exactly where it's going to be. I think the NAM has it kind of up here on the Oklahoma-Kansas border by 21Z or 4 p.m. Central Daylight Time. And then this is at 0Z. You can see surface low, kind of broad cyclonic circulation out here, and very clear where that warm front is. It's going to be up here into far northwest Oklahoma, far eastern Texas Panhandle into southern Kansas. And then we're going to have that dry line really set up and form that triple point. So this is going to be at 0Z, and you can see exactly where you need to be if this NAM solution were to verify. It's going to be right in here. Here's your warm front. Up in here, here's your dry line. So it's going to be right in here, somewhere up in far northwest Oklahoma, maybe west of the Buffalo area in Oklahoma, northwest of Woodward. If the NAM solution verifies, pretty clear indication of where you'd need to be, right at that triple point. That may be just enough. And you can see the surface convergence here on this triple point. You have winds to the south, almost due southerly to the south of it, and almost due easterly winds here north of that warm front. So that's going to be very strong convergence right at that triple point. Yesterday we didn't have quite as much convergence along that triple point, which may have been a little bit of a contributing factor to the lack of storm development yesterday. So, given the lack of forcing, I think the storm mode will be discrete for sure. We can check that using our shear vectors here, and you can see our dry line, which would help initiate the storms, and our shear vectors are almost due perpendicular to that dry line. So storm mode, given the lack of forcing, given the perpendicularity here between the orientation of the boundary, and the shear vectors aloft, discrete storms, maybe 1 or 2 storms at most, are possible to fire up here on that triple point. Let's take a look at a couple soundings here, just to kind of give you the parameter space, keeping in mind that this is the NAM, so we know the cool bias that the NAM has. So if we see surface temperatures in the low 70s, we're probably going to throw that out. And you can, this is concerning here. I mean, this wind profile, 600 meter squared per second squared effective storm relative helicity here. This is just an unbelievable photograph here, especially in the low levels. This is just a ton of curvature. And you can see that the NAM actually is completely uncapped, maybe a little bit of lingering sin, but that is definitely more than breakable here along that triple point. So this is actually quite concerning if this does come to fruition. If that cap does break, this parameter space is quite concerning, perhaps for a significant tornado. This would be a really good example of if the SBC were to ever do this, to put something like a 2% or a 5% hatched area in. They don't do that now, but we know the hatching is for the potential for significant tornadoes. The atmosphere is so conditional that the overall tornado threat is low, maybe like a 2%. But if storms do form, the supercells may produce strong tornadoes given this parameter space, which would warrant the hatching. So the threat for storms is very conditional today, but if they do form and sustain, my goodness, this is quite the profile here on the morning NAM. So that is going to be something that needs to be watched carefully. Is this cap going to break fully? And if we get a storm or two, that is going to be pretty nasty if that is the case. So let's see at 21Z here what the profile looks like. See where how that capping's doing. And you can see, you'll probably see here that we're going to maintain a little bit of capping, but you can see here the surface temperature at 75 degrees. Already large looping photographs up there on the triple point, but 75 degrees. Let's pick a spot up here in far northwest Oklahoma on that triple point just to see what the forecast temperature is. And again, these are forecast temperatures as well, so they may be inaccurate as well, but it gives us at least some sort of proxy we can look at. So 75 degrees here, high temperature of 82. So I would expect that this may be a little bit low and that we may already be uncapped here by 21Z. But we're going to have to watch that, of course, to see when storms may fire. But again, this profile here, if this comes to fruition, given that strengthening low-level jet after dark, this could be an interesting scenario if we do get a storm to fire and sustain itself. That's the key. Can storms sustain themselves into this environment? If so, need to watch out for potentially significant severe hazards, but again, very conditional threat at this point. So let's wrap this up here by looking at a couple of the cams. This is the 12Z HRRR, and I imagine we're going to see quite the spread of solutions here. You can see that elevated convection well north of the front up here across northern Kansas, and you can see not much here along that triple point. The HRRR maintains probably a little bit of capping here, and so storms are not going to fire according to the HRRR, this particular HRRR run. So let's actually take a sounding here. I would want to pull up the surface pattern here so we can see what the surface pattern on the HRRR looks like. You can see it does have that pretty decent triple point up in here. Perhaps mixes a little bit too much up here. You can see the dew points crater into the upper 50s up here on the triple point. Not sure if that's going to be the case. Well, the HRRR is quite uncapped. It does maybe try to fire some sort of convection here. There's a little bit of a signal. But it is a decently mixed environment, 86/65 here. But it is uncapped at this point. So at 0Z, 23Z, 6 p.m. Central Daylight Time, it is uncapped up here. So, and given this profile, decent veering of the winds in the low levels, something to watch for. The HRRR not quite firing storms, perhaps taking into account that subsidence, quite placing emphasis on that subsidence there. But again, it's uncapped here by 0Z. So something we're going to have to watch out for as photographs enlarge towards sunset. Could be something to watch if a storm can go and sustain itself. Let's look at the 12Z NAM 3 kilometer. And let's just go quickly through these cams just to give you the array of solutions that are on the table. This is the 12Z NAM here, and you can see it fires storms, actually quite a few storms up here on that triple point by 0Z, and allows them to sustain for a few hours. So definitely these would have a tornado threat as well as a large hail threat if they can sustain themselves, which the NAM 3 kilometer is showing that they do sustain themselves. Here's the WRF ARW by 0Z, does fire storms up there in kind of the Kansas-Oklahoma border north of Woodward, and they do sustain themselves for a few hours. So this is interesting here. We were seeing a lot of guidance yesterday that did not have storms at all for yesterday's event, and now we're seeing quite a bit of guidance that fire storms here. The NSSL WRF also on board with storm development on that triple point. So this is becoming a little bit of a concerning scenario here. All of the cams except the HER are firing storms. You can see the FV3 does fire storm. I mean, I don't know if I buy that kind of complex, but at least it does have a convective signal up there. So most of the cams are showing storms, a couple of storms up there on that triple point this evening. So given the enlarging photographs towards sunset, given the forcing the localized lift from that triple point, I do think a couple of storms are possible up here, up in far northwest Oklahoma, maybe as far west as the eastern Oklahoma Panhandle, up into southwest Kansas. And if they do fire, given the enlarged photographs near sunset, I do think a tornado threat is on the table. You know, dare I say a significant tornado threat. SPC, of course, does not have that outlined given the conditionality of the setup. But given the NAM profile that we saw, if this comes to fruition, this is a problem. Thinking back to past events in this area, you weather weenies out there probably know which one specifically I am thinking of right now in 2007. But this profile needs to be watched for the threat for one of those classic events where we get that low-level jet to ramp up after dark, kind of overcome that increasing convective inhibition near the surface, and you can get supercell maintenance there and perhaps significant tornadoes if storms sustain themselves in this environment. So large hail also going to be a threat today given the very steep lapse rates aloft, perhaps significant hail as well, both with the elevated storms north of the warm front and any supercell that does fire here on the triple point. So pretty interesting setup for today. We're going to wrap it up here. If you live in northwest Oklahoma, southwest Kansas here, definitely keep an eye on things. I think the confidence in storm initiation has increased a little bit from yesterday. So I do think that we will get a supercell or two up here into southwest Kansas, northwest Oklahoma here. Closer to sunset, probably initiating maybe as early as 5 p.m. or so, with all severe hazards possible. So with that, thanks for watching, and we will see you in the next video.